All right, here we are, SAT 22 for week 8, a non-multiple choice question. Let's read it. In triangle, right triangle ABC, angle C is the right angle and BC is equal to 162. Point D on side AB is connected by a line segment with point E on side AC such that line segment DE is parallel to side BC and CE is equal to 2 times AE. Wow, without a picture, that's a lot to process. Anyway, what is the length of line segment DE? Let's take a look at our results. Well, as you can kind of expect, answers all over the place whenever it is a student-produced response question. And there is one huge spike here at 54, which was 83.6%. That's pretty good, actually. And that was, in fact, the correct answer. Now, this is kind of interesting. How did we find our solution? Most of us phoned a friend. That's right. Came out on top over Desmos, and that friend could be your favorite AI chatbot or, just somebody who was able to figure out the answer. Now, this is also interesting. We thought this was our hardest question so far. You can see this is heavily skewed towards the 5 side of the really, really hard question. Here, let's get to the bottom of that, shall we? And it all starts with actually drawing yourself a picture for this thing. Once you draw a picture, maybe something occurs to you, even if you don't know the geometry that's involved. So we're going to start here with right triangle ABC, where C is the right angle. So I'll draw this right here, nice and large. Perfection. All right, we got ourselves a right angle, and we know that right angle is C, and the other two really don't matter, so I'll put an A and a B here. So far, so good. It also says BC down here is 162. Okay. And then we have two other points. We got point D, which is on side AB over here someplace. And we also have point E, which is on side AC someplace. And we want these segments to be parallel. DE and BC, the one that we said was 162. So I'm going to draw myself a parallel line segment right up in here. I don't know exactly where it's at, but whatever. And I know I have an E and a D. We have an ed or a D. Let me see, make sure I put those points in the right place. D is on AB. Okay, that's good. And E is on AC. And we also said that these things are parallel. So here's how that picture looks. So far, so good. Okay, so now we have one extra piece of information, which is crucial. CE is 2 times AE. Let me write that down real quick. CE is equal to 2 times AE. So let's say X is equal to AE. You can use anything that you want to. I'm going to use X. And then if X is what AE is equal to, here, I'll even put that on the picture, X, then how big is CE? Well, it's supposed to be 2 times what we said AE was. So that means that 2x is going to be equal to CE. So we'll just put that right there. Okay. And, all right, now what are we going to do with this? Well, there's a couple of geometry things that are going on here, and it's actually the relationship between the two triangles here. You may be going, like, 2 triangles, I only see 1 triangle. Well, we have nested triangles. We got 1 triangle inside of another triangle. Here, let me just kind of redraw them. So first of all, we have this little triangle here at the top, which is nested comfortably inside of the larger triangle, the right triangle that we were originally given. So here, I'm going to move this thing down here, and then maybe outline this thing so it looks presentable. There we go. Give it a nice outline. And we have a E here, and an A here, and a D, and the only thing we know is that this piece is X. And we're trying to figure out what the heck this guy is, right? Okay. And then here, let's do the same thing to the larger triangle. It's going to get some shading, and this is going to be the longest part of the video. Feel free to slow it down. Put it on like half speed. This should be nice and soothing. Maybe even a quarter speed. All right, we're almost there. We're almost there. Hopefully I don't go over over the lines. Okay, I got it. Success. All right, let's move this guy down here. Did I just delete that? Oh my God. Okay. Oh, got it back. All right, it needs an outline too, so it looks presentable. Now, of course, you don't need to do all this. I am just trying to help you understand exactly what is happening here geometrically, okay? Especially for the handful of us that missed this question. Okay, so let's label some stuff here. We got the 162, obviously, for BC. And then here's the important bit. AC, this is the whole thing here, this AC. AC is this x plus the 2x, meaning that AC, the whole thing, is actually 3x. Okay, and now here's the next part of this. Oh, I forgot this little guy, little right angle. Oh, and I just assumed this was a right angle over here. Ha ha ha. I didn't even discuss why that actually has to be a right angle. Let's discuss that now. So what this amounts to is something that is called the corresponding angles postulate, which we will absolutely talk about in a lesson coming not terribly soon, but at some point. Corresponding angles postulate. Postulate, same thing as an axiom. Anyway, so we're using this as a basis of other more complicated ideas like the one that we're doing right now. Okay, so it basically says that when you have parallel lines, and then we have another line that cuts across some lines called a transversal, the angles that are formed in the corresponding spots, that's here, this guy and this guy, have to be the same. So right angle, right angle. Not only that, we have another transversal, that's this AB here. This is the third line that cuts across our two parallel lines. And we have some more corresponding angles here that have to be congruent. And here, I'll mark these for you so that those have to be congruent. That makes angle D here and angle B also congruent. All right, and then there's another geometry postulate, which is the angle similarity postulate. Again, postulate, same thing as an axiom. Statement we don't have to prove, which says this, that if you have a pair of angles in one triangle congruent to a pair of angles in another triangle, those two triangles must be similar. So we put both of these things together, and it gives us some similar triangles. And you may remember from a previous math class that for similar polygons or similar triangles in particular, that means that their angles are congruent, and the symbol for that is equal sign with a squiggly on top, and their sides are proportional. And there's the hint for this whole thing. Sides are proportional. What this means is that I just set up a proportion with corresponding side lengths, and I should be able to find our question mark. This question mark down here. And if you want to be entirely algebraic about it, let's get rid of the question mark and put something in its place like, how about an A? All right, so now let's just go ahead and set up a proportion. And when you usually do this, you just find two sides that match up, and you write that as a ratio. I'm going to use x and the 3x. So that's going to look like this. So x over 3x is equal to, and then you pick two other sides and write them as a ratio in the same exact order. So that's going to be the a on the small one to the 162. So this a over 162. And we are almost done. So there was something I probably should have done right over here. This x over 3x, the two x's, x divided by x, 17 divided by 17, pi divided by pi, those things cancel out and give us the number 1 in their place. In other words, here, let me rewrite this for clarity. In blue, 1/3 is equal to a over 162. Now, if it's not obvious to you, What you're basically going to be doing is taking a third of this 162, so this fraction reduces to 1/3, or you can think of it as any other kind of proportion where you set the cross products equal to each other, and you go, hey, 3 times a has got to be equal to 162, so I need to divide by 3. So a is equal to whatever 162 divided by 3 is, which we can do this without technology to join the crowd. Wait, how much of the crowd did that? Without technology, 26.4% of students that answered this did it like so. So if I divide 3 into 16, that goes in there 5 times with 1 left over. 3 goes into 12 4 times, and we have our answer. Our answer is 54. We look at our results back over here, and 54 was the clear winner because it was the right answer. All right, see you next time.